Dear students, welcome back to yet another session on e-learning. I am Dr. P. Geeta, Associate Professor, EC Department, Hindustan College of Engineering and Technology. In this session, let us see about the various color models. Color models provide a standard way to specify a particular model by defining a three-dimensional coordinate system and a subspace that contains all constructible colors within a particular model. Any color can be specified using a model. Normally, the common color models used to represent are RGB Color Model, CMY Color Model and HSI Color Model. First, let us see about the RGB Color Model. So, the RGB Color Model consists of three primary colors, red, green and blue. They belong to the additive color model where two colors when added up form the third color. So, red and blue, the primary colors, when added, they form the secondary color magenta. Red and green, when added, form the secondary color yellow. And blue and green, when added, form the secondary color cyan. So, magenta, yellow and cyan are the secondary colors of red, green and blue in RGB model. So, these red, green and blue color, they form the axis of the color cube. And each point in the color cube specifies a specific color. And the cube is shown in the diagram in the next slide. So, these are the three primary colors, red, blue and green. And when they added up, you can see the secondary colors being formed. When all the colors are added up or when all the three primary colors are added up, it ends up with white color. Now, this is the color cube which shows the location of the color coordinates. You can see that the x-axis, it's represented by red, the green represents the z-axis and blue represents the y-axis. And cyan is combination of green and blue. From the cube, we can understand that the secondary colors are formed by adding two primary colors. So, the limitation of RGB model are, so they are device dependent, that is the RGB model will not reproduce the same color from one display to another. The next limitation is it is perceptually non-uniform, which means one unit of coordinate distance does not correspond to same perceived color difference in all the regions. Next comes the CMY color model. So, here the three primary colors are cyan, magenta and yellow. They follow the subtractive color model, and cyan is obtained when red is subtracted from white. Magenta is obtained when green is subtracted from white and yellow when blue is subtracted from white. So, printers employ the CMY model. The relationship between the RGB and CMY model is given as below. Cyan equal to 1 minus red, magenta equal to 1 minus green and yellow equal to 1 minus blue. So, here we can see the three primary colors cyan, magenta and yellow. When added up, they form a black color. And the secondary colors are formed when these primary colors are combined. That is, blue when combined with yellow forms green, yellow with magenta forms red color and cyan with magenta forms blue color. So this is the color cube where we can see that x-axis is represented by cyan, y-axis by magenta and z-axis by yellow. So when we combine yellow and magenta, you can see that we get red. So next is the HSI model. So here it is based on three parameters: hue, saturation and intensity. Hue is defined as the dominant color perceived by an observer. Like saturation, it is defined as the purity level of the color or how much of white is added to the color. If you have zero white, then we say that the color is completely saturated. Next, the intensity, it reflects the brightness of the color. This diagram shows the difference between hue, saturation and intensity. Hue, that is the parameter which differentiates different colors. Saturation, it is the amount of white added to the pure color, and intensity is its brightness. So this diagram shows the representation of hue, saturation and intensity. The HSI model is considered as a cone where the coordinates R, theta and Z are saturation, hue and intensity respectively. And this HSI model is popular because it is based on human color perception. HSI decouples the intensity information from the color while hue and saturation corresponds to human perception. Thank you for your patient listening. See you all in the next session. Thank you.